Hi guys, happy Monday. Welcome to week 7. So today we are going to learn how to apply some of the rules that we've learned. So the product rule, the quotient rule, the power of a power rule, and we're going to combine that into what's called the power of a product and the power of a quotient. We're not going to be using our workbooks today because the workbook doesn't specifically get into this. It keeps it more basic. But you do need to know how to apply and how to kind of use more than one rule at the same time. So we're going to do some notes and then go through some examples. And then you can do some practice problems, try them on your own, see how you do. And then there is an edge elastic. So just so you know, that's what we're going to do today. We only have math once today, as I said in the intro video. And then next week, we're going to wrap up with exponents. So I'm going to turn on my document camera. We're going to update the table of contents, and then we will get started. So what you're adding in today is the power of a product and quotient examples. And that's on my page 54. I'm not sure if it will take 1 or 2 pages, but we'll update that as we need to. And when you're done with that, we are going to tack onto the exponent rules table that we had set up a while ago. So if you could turn to page 49 and 50 when you're done updating your table of contents, we can go from there. Okay, so the last thing we talked about, sorry, this is not working out well for me. So the last thing we talked about was the power of a power rule. Sorry, I didn't have my ruler handy. Okay, so today we are going to do the power of a product and the power of a quotient. So I'm just going to draw here. And we have the power of a product. Okay. So the power of a product, that's like if you have 2 different bases, or if you have a coefficient and a base. So for example, let's say we have 3m, and that's being raised to the a power. What the power, and so it's a product because that means 3 times m, right? 3 times m. And that means I have 3 times m times 3 times m times 3 times m, however many times your exponent is. So what you have to do is you have to distribute that exponent to both the terms. So 3 to the a, and then m to the a. So however many terms are inside the parentheses, if they're all being raised to a power, each term inside, or if you have a coefficient, they all get that power. Okay? So we have keep the base, or bases, and then every term is raised to the power. Okay, so that's like if we have 2, or I'll keep 3m to the third. So what that means is I have 3 times m times 3 times m times 3 times m. Okay, so now you have your product rule, right? And so each exponent on the 3 times 3 times 3, that's 3 squared, 3 cubed. And then m times m is m cubed. So what I did was I took this 3 and I raised each term, or the coefficient and the term, to that exponent. So that's what gives me 3 to the third times m to the third, which is what we have down here. So that's the power of a product rule. And the power of a quotient rule is literally the same thing, except we're not talking about multiplication anymore. Now we're talking about division. Okay, so we have the power of a quotient. So the power of a quotient, that's like if I had 3 divided by m to the a power. I still give both terms that exponent. So that's 3 to the a divided by m to the a. Okay, and that's the same thing as we did up here. So if we had 3 over m cubed, right? That's like 3 over m times 3 over m times 3 over m. So now, right, when you multiply fractions, you multiply across. So that's 3 times 3 times 3, which is 3 cubed, over m times m, which is m cubed. Or if you just apply the rule, you distribute that third power to both terms, but it needs to be as an exponent. It's not times 3, right? It's 3 to the third over m to the third. Okay? So that's your power of a product rule and your power of a quotient rule. So now we're gonna do some examples. So turn to your page 54. And we're gonna do some examples that have a few rules linked together. So this is my page 54. So we have power of a product and quotient examples. Okay? So let's look at example 1. What if we have 2x to the 4th, y to the 4th cubed? So I'm going to expand it out to show you why it works. And then in the future, we don't have to do that, but you can if it helps you. So what that means is I have this 2x to the fourth y to the fourth times itself 3 times. So I have 2x to the fourth y to the fourth times 2x to the fourth y to the fourth times 2 x to the fourth y to the fourth. Okay, so if you look at that, we have 2 times 2 times 2. So that's like 2 times 2 times 2, right? Then we have x to the fourth times x to the fourth times x to the fourth, right? And then we have times y to the fourth times y to the fourth times y to the fourth. So I can write 2 times 2 times 2 as 2 to the third. And then x to the fourth times x to the fourth times x to the fourth, right? That's when you're multiplying bases, we add 4 plus 4 plus 4. So we get x to the 12th. And then y to the fourth times y to the fourth times y to the fourth is y to the 12th. So with smaller numbers like this, 2 to the third is 2 times 2, which is 4, times 2, which is 8. So we get 8 x to the 12th, y to the 12th. Okay, so this is the expanded version. If you were to take this 3 as the exponent and apply it as an exponent to every term, you would have 2 to the third times x to the fourth to the third times y to the fourth to the third. So again, you have 2 to the third, which is 2 times 2 times 2, which is 8. And then here you have a power to a power. X to the 4 times 3, which is 12. And then y to the 4 times 3, which is also 12. So see, we got the same answers. So this shows you why this works. And expanded form isn't always easy. It always works, but sometimes you can get really long problems. So let's look at example 2. All right, so let's say we have 3x, and that whole thing is being raised to the fourth, times 3x squared y cubed, and then that whole thing is being squared. So let's take it one step at a time. So the first thing you want to do is, can I simplify inside the parentheses first? No. All right, so let's do one at a time. So 3x to the fourth. So that's the power of a product. So I need to give each term inside the exponent of 4. So I have 3 to the fourth, and then x to the fourth. Okay, so I'm doing that, times. Now, inside this parenthesis, everything's as simplified as it can get. So I have to give every term including the coefficient, this is where most people make a mistake. I have to give each one of those the exponent of 2. So I get 3 squared times x squared squared times y cubed squared. Okay. Let's clean that up a little bit more. So I can't clean this one up, right? But I can clean this up. So I still have 3 to the 4th, x to the 4th. And I'm still going to multiply that by 3 squared. Now, x squared squared. I have a power to a power. So that's x to the 4th. And then y cubed squared. That's a power to a power. So I multiply 3 times 2. So y to the 3 times 2, which is 6. All right. I can simplify more. Do you see this 3 to the 4th here? That's a base. And this 3 squared is a base. So 3 to the 4th times 3 squared is 3 to the 4 plus 2. And then we have x to the 4th times x to the 4th. So that's x to the 4 plus 4. And then we just have y to the 6th. So your final answer is 3 to the 6th, x to the 8th, y to the 6th. All right, so take one step at a time and just keep simplifying. All right, let's look at example 3. So far, we've done powers of products. So now this one's going to be the power of a quotient. So this one we have 12x to the 4th y cubed over 3x y squared. All right, so for this one, I'm going to tell you to simplify inside parentheses first. It'll make your life easier. So, I'm sorry, all of that is raised to the 3rd power. All right, so let's look. Can I divide 12 by 3? Yes, 12 divided by 3 is 4. So I have 4. Then I have x to the 4th divided by x. It is not x to the 4th, it's x to the 4 minus 1, right? Times y to the 3 minus 2. And all of that is being cubed. So if I clean that up, I get 4x to the 3rd y raised to the 3rd power. So now I can give each term, think of it like the distributive property, that 3rd power there. So I get 4 to the 3rd, x to the 3 times 3, because that's the power of a power rule, and then y to the 1 times 3, which is just 3. So your final answer is 4 to the 3rd x to the 6th, y to the 3rd. And you could write out 4 to the 3rd because that's just 64. So you'd have 64 x to the 6th, y to the 3rd. That's your final answer. So now I'm going to show you an example of what to do when you can't simplify inside the parentheses first. So example 4. We have 15 m to the 3rd over 4x squared, and all of that is being raised to the 5th. So 15 and 4, I can't divide that out because we don't want to use decimals. So we leave that. And then I have two different bases, m and x. So I can't simplify first. So all I have to do is give every single term in both the numerator and the denominator. Is that blurry? The exponent of 5. So you get 15 to the 5th, right? Because the 15 has a 1 for an exponent. M to the 3rd to the 5th. So m to the 3 times 5 over 4 to the 5th x to the 2 times 5, because you have a power to a power. So this is where the most of the mistakes happen when you're distributing, if you will, distributing that exponent to the coefficients. Most students forget, or most students forget to distribute that exponent to the denominator. All right. So fully simplified, this would look like 15 to the 5th, m to the 15th, over 4 to the 5th, x to the 10th. And that's literally, I know that doesn't look simple, but that is as simplified as that answer can get. We can't do anything more. Okay? All right, last example. So example 5. We have 2x cubed times 3x to the 5th divided by 2x squared to the 4th. Oops, I used the wrong color. All right, so let's do this one step at a time, okay? So here you have a power, and the reason why you know that this exponent has to go to both is because there's parentheses. So I'm going to give each term inside the parentheses an exponent of 3. So that gives me 2 to the 3rd, x to the 3rd, times 3x to the 5th. We're not going to give the 3 an exponent of 5. Brisky. because there's no parentheses. So that 5 only belongs with the x. It doesn't belong with the 3. And that's, hi, Pace. That's divided by 2. So I have to distribute, no, Paisley. I have to distribute that 4 to the 2 and the x squared. So that's going to give you 2 to the 4th, and then x to the 2 times 4. So let's clean this up. I'm going to come, sorry, Amazon's delivering a package and it's not to me. So my dogs don't like it very much. So let's see what we can do. So I have 2 to the 3rd divided by 2 to the 4th. Well, I'm just going to do 2 to the 3rd, which is 2 times 2 times 2, which is 8, right? So I get 8 x to the 3rd times 3x to the 5th divided by, so now I have 2 to the 4th, which is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And then x to the 2 times 4 is x to the 8th. So let's look at this. So 8 times 3 is 24. So I have 24 x to the 3 plus 5, and 3 plus 5 is 8, over 16 x to the 8th. I can simplify 24 over 16. They're both divisible by 8. 24 divided by 8 is 3, and 16 divided by 8 is 2. So I get 3 over 2, right? X to the 8 minus 8. Well, this x to the 8th is going to cancel out with this x to the 8th, because x to the 8th divided by x to the 8th is 1. Just like 8 divided by 8 is 1. 10 divided by 10 is 1. It's not 0, and it's not x. So x to the 8 minus 8 is x to the 0, which we're going to get to next week is just 1. So that's like 3 halves times 1. So your answer, all of that simplifies to 3 halves. That's it. All right, so now you can practice on your own and then check the answer key and see if you have questions, and you know how to get in touch with me if you do have questions. All right, guys, I miss you. I hope you're all doing well. And don't forget to do we're going to do a whole pre-algebra check-in because our time on Friday is a little shortened. So we're going to do a whole family check-in around 150. 150. I'll put it up on Google Classroom as well. All right, guys, I miss you. I hope you're all well and healthy and socially distancing yourselves. All right, bye.